Okay, now we're going to be looking at problems 11 through 15. So I want to find all functions that are equivalent to 2x squared minus 8x plus 6. Okay, so now I'm going to have to do a couple different methods in thinking about what we have. So some of you may feel better about putting it into vertex form first by completing the square, averaging an equal value, like plugging in 6 for y and solving it. Others might feel better to factor it first. Choose whichever one you want to do. But when it says all, you should always start thinking there's probably going to be two answers. So this one's really set up to be two answers. Okay, so first thing I'm going to do is I've got 2 in common. So I'm going to factor it first. So I got y equals 2x squared minus 4x plus 3. Okay, this one factors pretty easily because there's only one way of getting 3, and that's 3 times 1. It's positive, so signs are the same. Negative means they're both negative. So 2x minus 3, x minus 1. So I know one of my answers is D. Okay, now, choices in terms of the vertex form, you could use the answer we have right here. Since I've got these values and I want to find out where the x-intercepts are, I have x equals 3 and x equals 1. If I average these two, my vertex is going to happen at 2. Average of 3 and 1, or halfway between 1 and 3 is 2. Then I've got to go back and plug into the equation up here. So sometimes plugging in, because you don't get to use a calculator on the midterm for this part of it, at least the multiple choice. For your response, you get to use a calculator. Well, we do 2 times 2 squared minus 8 times 2 plus 6. I have 4 times 2, that's 8, minus 16 plus 6. So I get negative 8 plus 6, or I can do 6 minus 16, that'd be negative 10. 8 minus 10 is negative 2, whatever it takes to kind of figure this out. Then my equation is y is equal to, I've got x minus 2 squared, we do the opposite, is shifted down 2, and my a value is the same as the original. So I can find it that way. The other way is, some of you feel more comfortable with like completing the square, so I'm going to do completing the square on this. And if you take this equation, I can start by subtracting 6. I'm going to factor out 2. I'm going to leave a space. Now I take half of negative 4, that's negative 2. I square it, I get plus 4. If I add 4 here, I actually added 2 times 4, so I got to add 8 to the other side, so I keep everything balanced. Now I've got y plus 2, 2x minus half of that term was 2, and I got my equation. So either method you use, the answer would have been C. So C and D on that one. Problem number 12. Okay, some rules of exponents. So be careful when you work it. Just take them slow. So what I'm going to do is I've got to do my raised to a power first and be careful on each step. So I'm going to do 2 raised to the third. That's 8. Then I have x to the negative third raised to the third. I multiply my exponents, I get x to the negative 9. This is y to the first raised to the third, I get y cubed. Now I'll bring in the square here. I have x squared squared. So I do x and take the exponents, multiply them. 2 times 2 is 4. And I have y to the fourth squared, that's y to the eighth. Over 6x negative 2 y to the fifth. Okay, so now I'm going to take care of my numbers. 8/6, that reduces to 4 over 3. I'm going to combine I'm going to simplify the top before I try to deal with anything else with the bottoms. So I have x to the negative fifth, y to the 11th, x to the negative 2, y to the fifth. And then there's a couple different methods. The one I like to use is I think, okay, I'm missing 5 x's on the top. I'm missing 2 on the bottom. I'm missing more on the top than the bottom, so I'm going to multiply top and bottom by what I'm missing. X to the fifth, x to the fifth. This gives me 4. I have x to the 0, so I just have y 11th left on top. I do x to the fifth times x to the negative 2. Y, take away 2 from the 5, I get x cubed. And then we had y to the fifth. So, but I could have simplified this at the same time. I just took care of my x's first. 11y is on top, 5 on the bottom. So I got 4y to the 6th, x cubed. And I forgot to carry my 3 each time. So the answer here was B. Okay, question 13, working with box plots. So we want to make sure we understand how the box plots kind of work. This one's done with the parallel box plots, where the box plots are done vertically. This would represent the score on the test. The lowest point was the minimum score. The highest point was the highest score. This is the 25% mark, 50% mark, 75% mark. This is the median, this line right here. So when we talk about averages, this is where the averages are. So right here, on average, this is higher than this. They had a higher average. The median is the average. And that's the kind of thing you actually use for test. Testing is better to look at a median because you tend to have some extreme scores, like somebody might score really poorly on a test, and that throws off things like the mean. Or if you had a really hard test, you may have somebody who just scored really well on the test and everybody else kind of scored in the lower area. So this, on average, the score was higher. So on average, Adam's class scored better than Ben's. Okay, other things we want to look at. Well, if you look at the size of the boxes, these ones are a lot tighter, a lot smaller, which means we have less spread. This has more spread. We use the interquartile range to measure spread. So this one right here is more spread out than this one. So therefore, Ben's class was more consistent. Now be careful with this. I have no clue about how many scores are in either one of these. This one could have 20 scores, and this one could have 100 scores. This one could have 200 scores, and this would have 10 scores. We really don't know anything about the scores. We just know what the 50% mark was, the 25%, the 75%, max and mins. That's it. So we have no idea about how many scores there are. Okay, they look like they have the same 25% mark. So for both classes, 25% of the students would have gotten below 50, looks like. Okay, equation of a circle with center at -3, 2, but passes through the origin. So if I think about what's happening here, I'm going to have to use Pythagorean theorem to figure out what my radius is. So my center's at x is -3, 2. I've got x plus 3 squared plus y minus 2 squared. Now I've got to find out what r equals. And it's r squared. So if I'm going to go from -3, 2 to the origin, -3, 2, and I'm going to the origin. Well, it's just Pythagorean theorem. This side's 3, that side's 2. So 3 squared is 9 plus 2 squared is 4. 9 plus 4, the hypotenuse is square root of 13. So my radius equals the square root of 13. That is r squared. So I want it to equal positive 13. So I want x plus 3 squared, y minus 2 squared is equal to 13. So there's my answer there. Okay, question 15. I want to know what is the equation to the graph at the right which passes through the point negative 4, 2. Okay, you should recognize this is a cubic. One thing is, it is negative. So that should come out when I solve for my a value. So I can tell right here, this is shifted to the left 2, down 1. Okay. So that tells me I've got x plus 2 cubed minus 1. Then it's y equals a times, and I'm going to solve for a. So now I'm going to plug in this point negative 4, 2. So y equaled 2 when x equaled negative 4. And if I do everything correctly, I should get a negative answer. Negative 4 plus 2, that equals negative 2. Negative 2 cubed is negative 8. So I'm going to add 1. That's going to give me 3. So A is equal to negative 3/8. So I'm looking for negative 3/8, x plus 2 cubed minus 1. That answers A.